Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everyone feeling today?
I'm good.
Good, good.
Yeah.
How's the midterm for everybody?
Question three was hard.
Question three, yeah, that
Yeah.
one was depending on how you did it, you could have either done a lot of calculations or not. But yeah, I
Yeah,
think
I was just confusing a little bit about when we have a G in the problem. I was
yeah.
confusing about the year.
Mm-hmm.
So it was a little bit challenging, but I did all the steps. I tried to do the principal
Mm-hmm.
way, but I found that I have to do the LCD for the 6 and 8 and 10 years. It'll be
Mm-hmm.
120, so it will
Yeah.
be long. So it's not gonna work out.
Mm-hmm.
So I end up doing the annual cash flow,
Mm-hmm.
but I think
Yeah,
I did good.
that's good. That's good.
The other two questions wasn't like that hard. Just like need to have like a flow chart and like just set up the problem. You'll be fine.
That's
I
good. That's
spent
good.
3 hours on that number 6 problem.
Yeah, depending. Yeah, I guess we talked about it last night. Yeah, depending on how you do it, you can either do a ton of calculations or it could be a little bit easier. um, but yeah, so I haven't had a chance to grade them yet. So, I just finished grading a midterm for another class this morning. So I'll probably get to you guys' midterm after the class today. So I guess after the class we have office hours. So either during that or and I'm hoping to finish by the end of today. But I haven't looked at it yet, so I don't really have a sense of what the average is or anything like that. But either by the end of today or tomorrow morning, you guys should have the exams.
So
Yeah.
by the end of the day, we'll probably have grades.
That's my goal. But if I don't finish, then by tomorrow morning for sure, you'll have. Yeah. Okay. So that's good. So it sounds like yeah, feel free to discuss the exam now. That's totally fine. Okay, so the plan for today is we're going to finish up our lecture notes on rate of return. So we don't have too much left. We just have like 3 more pages to go. And then we're going to start our next lecture notes on kind of the, I kind of think of them as like all the other analysis tools. So like by the time we finish today, we'll have finished kind of like the big 3 of the economic analysis tools and engineering economics, which is present worth analysis, annual cash flow, and rate of return. So those are kind of the 3 that typically is gone over in detail. And then there's some others that could be useful in practice or might be mentioned in other places. So I just want to take kind of a brief, maybe lecture, maybe half of next lecture to kind of go over that. Okay. So before we get started, are there any questions on just anything that we've covered so far, or anything I can answer before we start? Okay. So let's go ahead and pick up where we left off. So I think where we left off last time was this idea of incremental analysis. Okay? And so we've already covered kind of the basics of rate of return, which is it's a kind of a different approach to how we do these kinds of problems. So for rate of return, remember what we're looking for is not a cash flow, which is what we do for present worth and annual cash flow. So we find some kind of dollar amount. But for rate of return analysis, what we're looking for instead is the interest rate. Okay? And so we did a bunch of examples last time on how to do this for kind of single use cases or single projects. But turns out you can actually use rate of return analysis to also do comparisons. So same way that we did present worth analysis and same way that we did annual cash flow. So you can use rate of return to compare and see which alternative is better. Okay? And where this is typically used the most, kind of going off the name of rate of return. And so rate of return, is the interest rate, but you can also think of it as the percentage of money that you're going to make from an investment. So this is typically used to compare 2 investments. And so the way that we did that was say we have two investments. And so the way that you perform incremental analysis is you basically add up all the cash flow together from the 2, okay? Or you subtract them from each other. And so the way that we typically did that was we took the higher cost alternative. Okay? And then we subtracted from the lower cost alternative. Okay? And then from this, we get a new set of cash flows from this difference between the 2. And then from this new set of cash flows, we can compute the rate of return. Okay. And then, you know, that rate of return is going to be some percentage, right? Something between 0 and, you know, not too high. And so what we want to do at this point, after we computed the rate of return of the difference, is that we want to compute it, we want to compare it to what's called the MARR. Okay. And so remember, MARR stands for the minimum attractive rate of return. So you can kind of think of it as kind of like the baseline interest rate. Okay. And so, you know, depending on how our rate of return compares to the MARR, you know, we can either do two different things. Okay. So we'll call this guy IRR. Okay. So IRR stands for internal rate of return. So in case IRR is greater than MARR, okay, in this situation, what we're going to do is we're going to put our investment into the higher cost alternative. Okay. Okay. But if the IRR is less than MARR, okay, what we're going to do instead is we're going to choose the lower cost option. And then by doing so, you know, we can say that because the lower cost option has lower initial cost, we can invest the rest of that in the MARR. Okay. All right. So question in the chat. Can I repeat what MARR stands for? Yeah. So MARR stands for minimum attractive rate of return. I don't think it's going to fit, but. Okay. So the MARR will be something that's usually given to you in the problem, and it's usually some kind of market rate or some kind of like interest rate that the bank would give you. Okay. Okay. And so that's the idea with incremental analysis. And so I think where we left off last time is actually in the middle of an example. But I just wanted to just quickly review kind of what we're going over before we jump back into that example. Are there any other questions on this before we continue with the example? Okay. Okay, so let's go back to our example. So our example here was pretty simple. Okay? And so we were considering two options. Okay. And so let's do option 1 or alternative 1. And then we'll have alternative 2. Okay. Okay. So these are very short-term investments. Okay. So let's say that in year 0 for alternative 1, we're going to pay invest $1,000. Okay. And then for alternative 2, we're going to invest $2,000. Okay. And so, you know, because these things happen in year 0, these are our initial costs. Okay. And then 1 year later, if we choose option 1, we get $1,500. Okay. And then option 2, what we get is $2,800. Okay. And so what we did first was we took each of these individual options and then we computed their rate of return. Okay. So for this guy, option 1, we have a 50% rate of return. Okay. So that's pretty easy to calculate because we, you know, we paid $1,000 and then a year later we got, you know, we increased that by 50%. Okay. And then for alternative 2, our rate of return was 40%. And so it's tempting at this point to say that, you know, because we get a better rate of return on alternative 1, we should pick that one, right? But I think where we left off was actually computing the difference. Okay? And so if we set up the increment, so the increment, remember, is going to be the higher cost alternative minus the lower cost one. So in this case, the higher cost alternative is alternative 2. Okay? And so we're going to put that one first, right? And so if we do alternative 2 minus alternative 1, for the initial cost, we have minus 2,000 minus 1,000. So that's going to be minus 1,000. Okay. And then we're going to subtract the benefit here. So we have 2,800 minus 1,500. And so we have 1,300 right here. Okay. And then for this particular problem, the MARR is going to be 10%. Okay. And so the way, and so you know, at this point, you know, we haven't determined yet what's the best option because we need to do the rate of return of the difference or of the increment. Okay, so let's go ahead and do that. And so the rate of return of the difference And so since this is a pretty simple case, it's just a 1-year investment, we can just use the formulas, okay? And so if we basically, you know, compute the present worth and solve for I, okay? Okay. What we get in this case is a minus 1,000. Okay, plus the 1,300. Okay, and if we're going to compute this to a present sum, this is going to be P over F, I 1. Okay, and this is going to be equal to 0. Okay, and if we use the tables, or you can use the formulas, what you get is an I is equal to 30%. And so we have a 30% return in our investment from the difference. Okay. And so this is our IRR, or incremental rate of return. Okay. And so let's compare this incremental rate of return of 30% to our MARR. Okay. And so there is our 30% is our incremental rate of return, and then our MARR is only 10%. Okay. So in this particular case, our incremental rate of return is bigger. And so in these situations, you know, what you pick is the higher cost alternative. Okay? So in this case, the higher cost alternative is alternative 2. And so we're going to pick alternative 2 in this case. Okay? All right. Any questions on this? I'll debrief it a little bit more on the next page too. Okay. Okay. And so, you know, you might be saying that this is still a little bit non-intuitive because, you know, for option 1, you know, we get, it's more efficient. So we paid, you know, $1,000 bucks, we get 1,500 back. That's, you know, that's a 50% rate of return. So, you know, how can option 2 be a better option than option 1? Okay.
Professor?
Yeah.
Could you go back to that last slide?
Sure.
Sorry, I just needed to write the rest of that down.
Oh yeah, no problem, no problem.
Wait, why did you pick option 2 again?
Yeah, yeah. So I'm going to explain on the next page. Yeah. Okay. Okay. So it still might seem a little bit unintuitive to, you know, why we're picking option 2, because, you know, it seems like it's less efficient, right? But I want you guys to think about it like this, okay? And so, you know, the fact that we're even considering option 2, remember option 2 had an initial cost of $2,000, right? And so you can think of it as saying that, you know, we have $2,000 that we are free to invest. Okay, so that $2,000 is fixed, and so we want to basically choose the most efficient way to invest this $2,000 to kind of maximize our return on our investment. Okay, and so let's say that we went with option 1. Okay, and so with option 1, we're going to pay $1,000 out of this $2,000. And then that's going to turn into $1,500. Okay. Okay. But, you know, by choosing option 1, you know, we've only spent half of the money that we actually set aside to begin with. Okay. So after we choose option 1, you know, we'll still have $1,000 left. And we'll assume for this case you can't double dip. So you can't do option 1 twice. So the reason why it's like that is because you can only do it once. Okay? And so what you're going to do with this $1,000 left is that you're going to invest it at the MARR. Okay. Remember, our MARR in this case is only 10%. Okay. Okay. And so if we invest that $1,000 at the MARR with a 10% rate of return, we're only going to get $1,100 from this. Okay. And so if we add up kind of our future sums here, so we had one future sum by choosing option 1, and then we have another future sum here by investing at the MARR. And then what we get is just $2,600. Okay. So for our $2,000 total investment, we only make $2,600 from this. Okay. Versus if you picked option 2. Okay. So in option 2, we invest the entire $2,000 into one account, and then what we get is $2,800 from this. Okay. And so if you compare this $2,800 to the $2,600, obviously $2,800 is more than this. Okay. And so for these kinds of problems, remember you're comparing two different investments, and you want to see what's the most efficient use of all of the money that you could invest. Okay. And so if you place the upper limit of your investment on the higher cost alternative, then you can kind of see what's the most efficient way. So, if we chose option 1, our first $1,000 we invest, yes, we get a better rate of return on that. But for the rest of that $1,000, we're only going to make 10% off that. So overall, option 2 is going to be more efficient here, and that's exactly what this incremental analysis is illustrating to you. Okay. Does that make sense to everyone? Are there any questions on this? Okay. Okay. And so that's kind of the basics of incremental analysis. So you can basically use the same tool for a lot of the same problems that you did present worth analysis and annual cash flow, with the caveat that you can only do 2 at a time. So once you do more than 2, it actually gets to be exponentially more complicated. Okay. But let me just talk about just briefly on what if you want to do incremental analysis when the projects have different lives. So, kind of goes back to the discussion on the midterm question that we talked about at the beginning. Okay. So with the rate of return, you still, have to take this into account. The fact that, oftentimes with different project lives, you have to buy replacements. So I think this is kind of best illustrated with an example. Okay. So in this example, let's say that we're considering 2 different machines for purchase. Okay. And so we'll call the first machine, we'll call it machine X. Okay. And the second one we'll call machine Y. Okay. And so these are the types of cash flows that they have. So they're going to have a initial cost. Okay. There's going to be a uniform benefit. So you can kind of think of this as like a revenues. Actually, let me write that just to save some space. Okay. They both will have a salvage value. Okay. And then we also know that they're about their lives, okay? Or how long they're gonna last, okay? And so machine X, let's say that has an initial cost of $200, okay? The annual revenue will be 95. The salvage value will be 50, okay? And it's gonna last for 6 years, okay? Machine Y, it's gonna be 700. Revenue is gonna be 120. The salvage value will be 150. And it'll last 12 years, okay? And so since we want to perform comparisons between these two, we also need to take the difference between them in order to compute incremental analysis, okay? And so in this particular case, when you're considering, which one is the higher cost alternative, you kind of ignore just the product lines for this. So in this case, machine Y, because it costs 700, that's the higher cost alternative, okay? So we're gonna do machine Y minus machine X, and what we get is minus 500, and then 25, 100, and then for the difference, we're gonna pick the least common multiple for these guys, okay? Okay, and so if we have an MARR of 10%, we want to find out which machine that we should purchase that's going to maximize our kind of return on investment. Okay. And so first thing that we'll start with is that we'll compute the present worth of the difference. Okay.
Professor, for the life, for the difference of life, shouldn't it be 6?
No, it's going to be the least common multiple for this one, so it's going to be 12.
Oh.
Yeah.
Oh.
Yeah, so that means for machine X, we're going to need to buy a replacement in year 6, but we'll deal with that probably on the next page. But yeah, that's definitely an important consideration to do.
How do we get MARR? Is that the revenue divided by the life?
The MARR will usually be given to you. So the MARR is kind of like the standard. So when we do incremental analysis, we're computing a rate of return right there, and then depending on how that rate of return compares to the MARR. That's going to tell us how we should invest our money. But the MARR is always going to be given to you. Okay, so the present worth of the difference will be the following. So first we have our initial cost. We have minus 500. Okay. Then we're going to add our revenue. Okay, so this is going to be a plus 25. That's going to be P over A, I, 12. Okay, so remember, we don't know the interest rate. We're going to add our salvage value, so it's going to be 100, and then P over F, I, 12, okay? And so, if these two machines had the same, if they both lasted 12 years, we can just simply compute I off this guy, okay? But in this case, because machine X only lasts for 6 years, we're going to need to buy a replacement in year 6, and that's going to also affect our cash flows, okay? But I'll do that on the next page. Okay, are there any questions on this? Okay. Okay, so now let's factor in the fact that we have to buy a replacement in year 6 for machine X. And so if we draw the cash flow diagram for this, and so I'm just going to draw just kind of one thing at year 6. Okay. Okay. And so in year 6, we have to buy a replacement. So that means we're going to salvage our first one for 50 bucks. Okay. So we have positive cash flow of 50. Okay. And then we also have a negative cash flow of minus 200. Okay. Okay. And so if we compute the present worth of this, this would be 200 minus 50, P over F, I, and 6, okay, because it occurs in year 6. And so this is A. This is a minus 150, P over F, I and 6. Okay. And so this minus 150 right here, this is a cost that's exclusive to machine X. Okay. Because a machine Y, because machine Y is going to last all 12 years, we don't have to do a replacement for this.
Professor?
Yeah.
I'm not sure if I missed something, but should that be a positive 150?
Right now it's negative because we're just considering it for machine X. But if you're looking in the lecture notes, I've kind of already done the next step, but we'll get there in kind of just a second.
Okay.
Right. And so what that was referring to is we need to factor this into the present worth of the difference. Okay. And so remember, the present worth of the difference is going to be machine Y minus all the costs and benefits of machine Y minus the costs and benefits of machine X, right? Okay. And so since machine X right here is on the other side of this negative, and so basically, if you look at kind of the way that we computed this difference over here, was we took everything in machine X and then we just subtracted. Okay? And so what we're going to do is the same thing here. So even though this machine X is a negative, or this replacement cost for machine X is a minus 150, the fact that we have this other minus sign right here in the present worth of the difference means that we're going to add 150 to our present worth of the difference. Okay. And so to this, from the previous page right here, we're going to add this 150 P over F I 6. Okay. And so this total expression right here that I have on the bottom right here, this is the expression that we're going to use to compute the rate of return. Okay. And we only added this, we added this 150 here because this reflects the replacement cost of machine X that occurs in year 6. So you have to be really careful with the signs here because it can be really tricky. So if you have to replace usually the ones that have to be replaced are the ones that are the cheaper alternative because they're cheaper and they usually don't last as long. And so usually the replacement cost is going to be a positive for the present worth of the difference because you're going to subtract that cost. Okay? So you do a minus minus and then it ends up a positive.
Wait, why is it a positive again?
Right, because this 150 right here, if we went with machine X, we would have to spend a net minus 150 in year 6 to replace it, right? Because we salvage the first one for 50 bucks, and then we buy the new one for 200, right? So we have minus 150 P over F I 6, right? But because we're not solving for the present worth of machine X, what we're solving for is the present worth of the difference between machine Y minus machine X. And so we have two negatives here. So we have this negative right here that's associated with just the fact that we have to buy a replacement, and then we have this other negative right here when we're computing the difference in between the two. So we have a minus minus, and then they're going to cancel each other out and become positive.
Okay, thanks.
Yep.
So in your equation, should it be 50 minus 200?
Yes, there's your 50 minus 200. Thank you.
Okay.
I was kind of already. That's what you were referring to for
Yeah.
positive. Yeah. Thank you. I was jumping ahead of myself a little. There you go. Okay. Okay, and so now that we have this full expression here for the present worth of the difference, okay, now we can start plugging in values of I from the table because this is a little bit, there's quite a few values here, so it'd be hard to do by hand unless you're using plotting software. But let's use the tables. Okay, and so let's start at 1%. Okay, and so if you find the present worth at I is equal to 1%, so you basically plug in values from the 1% table, and then what you get is a present worth of 11. And then you can do the same thing for 1.5%. And so what you get from 1.5% is a present worth of minus 6. Okay? And so what this tells us is that the IRR is somewhere between 1 and 1.5. Okay. And so at this point, you can perform some interpolation in order to find the exact rate of return. But in this case, it's you could do it, but it's not going to be necessary, because if you remember our MARR from the beginning, our MARR was given to us as 10%. Okay. And so no matter if it's 1 or 1.5, the IRR is always going to be less than MARR in this case. Okay. Or not always, but no matter what we interpolate, it's going to be less than the MARR.
What are the top two numbers again? Like, how do we find 11 and -6?
And so the way we found those was we have this equation right here for the present worth, right? And so what you can do is you can go to the compound interest tables, and then you can go to the table for, we start at 1%, and then we fill in all of these factors here for, all these terms in parentheses over here. And so it's basically just a plug and kind of guess and check kind of thing. And so that's kind of what we did, a couple weeks ago for that. And so I kind of just, I kind of just skipped over those calculations. I just gave you kind of the end result for this. Yeah.
And it's in between 1 and 1.5 because it swaps signs, correct?
Exactly, right. Yep.
Cool. Thank you.
Yep. So since it goes from positive to negative, that tells us that the IRR is somewhere in between those two. So no matter what, it's always going to be less than the MARR. And so in these situations, we choose the lower cost option. Okay. And so in this case, lower cost was machine X. Okay. All right. Any more questions on this example here? Okay. Okay, so that's incremental analysis. So if you want to use rate of return to perform comparisons, that's basically how you would do it. And so the last thing I want to go over is some complications that can occur. And so if you remember, if you think back to when we did present worth analysis, we ended that unit on kind of a weird example where present worth didn't really give us any reliable solutions, because depending on what interest rate we chose, we could have either said that it was a good investment or a bad investment. Okay? And so in these, so I want to go back to that example because rate of return kind of gives us the toolkit to analyze it. And in particular, we're going to look at something called a modified IRR. Okay. But to kind of motivate this, let's kind of go back to the example that we did before. Okay? And so if you remember from this example, what we were doing was, you're like an employee at like a mining company. So say you're mining like precious metals or precious jewels, and then you were wondering if you want to invest in a certain plot of land, where you can do some mining. Okay? And so in this particular case, say that we compute the present worth. Okay? Purchasing this land will have an initial cost of $610,000. Okay? But then after you buy the land, then it's going to make you $200,000 in revenue each year. Okay? Okay? For 10 years. And let's say that we don't know the interest rate yet. And then at the end of those 10 years, just due to kind of environmental protections and stuff like that, you have to kind of clean up the land that you kind of that you were working on. Okay? And so instead of a salvage value, remember this problem was unique because we had a salvage cost. And so at the end of 10 years, we had to pay $1.5 million. Okay? And so that's going to be another minus 1.5 million. And since this is a future worth, it'll be just like that. Okay. Okay. And so, you can definitely find the rate of return in this case, or you can try. Okay. But I'm going to solve this with the plotting way. Okay. And so if we plug in formulas, for P over A and P over F. Okay, and then we plot the results. Okay. It's going to look something like this. So on the x-axis here we have I, and on the y-axis here we have present worth. Okay. And so if we look at around 4% and around 18%, okay, our graph will actually look something like this. So our graph is going to come up and it's going to cross the x-axis at 4%, and then it's going to dive back down and then cross it again at 18%. Okay? And so remember, you know, when we were solving these problems with plotting, you know, the rate of return that we compute is the location where the graph crosses the x-axis. And so since this graph crosses the x-axis twice, you know, this means that we've found two rate of returns. And so, you know, for these cases, when you have two rates of return, you know, the question is, you know, which one do we actually use for our solution? Okay. And the answer to that question is not clear, because, you know, they both, you know, show that, you know, that this investment here can either return a 4% or an 18% rate of return, just because, you know, it crosses the x-axis twice. Okay. And so in these particular cases, it's not clear which one you can pick. And so this kind of explains why we got those like really weird results at the end of present worth, where I think we did one present worth at like 3%, and then we did another one at like, you know, 8%, something right here. You know, and when one of us gave us a minus sign and one of them gave us a positive result. Okay? And you know, the reason for that is because this rate of return thing crosses the x-axis twice. Okay? And so these kinds of results right here is a multiple root problem. And so in these situations with multiple roots, you know, we need to kind of change our approach a little bit in order to get a result that makes sense. Okay? And so the approach that we're going to take is called the modified rate of return. Okay? All right. Any questions on this? Okay. Okay, and so you know, let's go over some different scenarios for, you know, multiple roots, okay? Because actually, you know, sometimes if you have multiple roots, sometimes it can still be okay, actually, believe it or not. Okay. Okay. And so if you have a multiple root situation, and you know, if you have one of the roots to be negative and one of them to be positive. In these situations, you're actually in luck, because, you know, a negative rate of return doesn't really make any sense. And so in these cases, you know, you just pick the positive one to be your IRR. Okay. But, you know, as you saw in kind of the previous figure, we could have situations where both roots are positive. Okay. And so in these cases, we compute the modified IRR. Okay. And the way that we do that is going to follow this this recipe right here. Okay. And so to compute the modified IRR, the first thing that we have to do is draw our cash flow diagram. Okay.
If we get 2 negative roots, then will we expect that we did something wrong?
If you get 2 negative roots, then it's probably a really bad investment, and you probably shouldn't be doing it. That's usually what it means. But yeah, it's rare, because usually you know, these things you'll get at least one thing that shows you're going to make some money off of it. Yeah. At least in this class, but in real life, you know, anything can really go. Okay. And so after you draw the cash flow diagram, what you're going to do is you're going to combine all cash flows in each period into a single sum. Okay. And so as a result of this, you know, for each notch or each node in your cash flow diagram, you should have just one arrow. Okay. Okay. And so the next thing you're going to do is you're going to find the present worth of all the costs. Okay, so for all the negative arrows in your cash flow diagram, you're going to compute all of those to a present worth. Okay. Okay. And then the interest rate that you're going to use for this is the financing rate, okay, which will be given to you. And so the financing rate, you can kind of think of it as, you know, the fact that companies usually, when they take out loans for investments, they usually pay at a certain rate. Okay. But when they want to get returns on their investment, they want to, you know, do that at a higher rate. Okay. And so, you know, that's reflected here. So after you've found the present worth of all the costs at the financing rate, you're going to find the future worth of all the benefits at the investing rate. Okay. Which again, you know, the investing rate will be given to you for this problem. Okay. And so from this, you'll have two values. So you'll have, you know, one value that's the present worth of all the costs, and the next value will be the future worth of all the benefits. Okay. And then the way that you compute MIRR, which is the modified rate of return, will be given on a formula on the next page. But before I do that, are there just any questions on this? Okay. Okay, so once you have these two things, then you can plug it into the formula. Okay. And so this formula is going to be 1 plus MIRR. Okay. And this can be raised to the n power. Okay. And you're going to multiply this by the present worth of the costs. Okay. Plus the future worth of the benefits. Okay. And this is equal to 0. Okay. And so once you have, you know, once you have this guy, and then once you have that guy, which is the present worth of the cost and the future worth of the benefits, then you can solve this equation for MIRR. So that was kind of a lot going on right there. So I think you know, I think the best thing to do is to, you know, do an example of this.
What's
So,
is that like an exponent or something?
Yeah, yeah. So this is n right here. So this is going to be the length of the period.
Okay.
Yeah, yeah. So that'll always be given to you as well. So how many years the investment's going to take place. Okay. And so let's do our coal mining example from before, and then let's compute the modified rate of return for this guy. Okay, so the first step we're going to do is we're going to draw our cash flow diagram. So in this case, we have 10 years. Okay, and so we had an initial cost of $610,000. Okay. Okay. Then we had a uniform benefit of $200,000 each year. Okay. Okay. And then at the end, we have a salvage cost of 1.5 million. So we can express that as 1,500K. Okay. And so we want to compute the modified rate of return. So we need the financing rate and the investment rate. Okay. So let's assume that our I finance this is going to be 8%. Okay. Okay. When our investing rate is going to be 15%. Okay. And you can see that we have 10 years. Okay. And then what we're going to do here is compute MIRR. Okay. All right. And so that's the problem. And so the first thing that we're going to do is we're going to take our cash flow diagram here and then modify it so that we only have just one arrow on every node. Okay. And so this is true for most of the nodes here. The only one where it's not true is this guy, the last one. Okay. And so on the last node right there, we have one arrow going up, which is our revenue, and one arrow going down, which is salvage cost. Okay. And so let's combine this. And so instead of having those two guys right there, let's say that instead we have just one arrow going down. Okay. And this is going to be 1,300K or $1.3 million. Okay. My stylus it's always a struggle. Okay. And so, when we're computing the present worth of the cost and the future worth of the benefits, we're not going to consider the benefit on year 10. We're just going to lump it together as one lump cost of $1.3 million because we're simply just going to add the 200K from the revenue minus the 1.5 million salvage cost. So in the end, we just get 1.3 million for that guy. Okay. Any questions on that? On how we combine those two?
Did you just combine them to like simplify the math?
So that's part of it, but that's just kind of the way that's the modified rate of return is computed. So when you have kind of multiple arrows like this, then you don't really compute the exact same modified rate of return. So it's kind of just the method that they use to do this, but partially it is also to simplify it as well.
Okay, thank you.
Okay, and so let's continue with the calculations. So the first thing we're going to do is the present worth of all the costs. And so we have two costs right here. So we have the minus 600K at the beginning. Okay. Is it 600K or 610? It was 610. Okay. And so 610 is already in the present day, so we don't need to do anything with that. Okay. Okay. And then we also have a 1,300K or 1.3 million in year 10. Okay. And so remember, we're going to use the financing rate here. So our financing rate is 8%. And then this is for 10 years. Okay. All right. And so if we compute this, we plug in values from the table, we get minus 1,202.16K. Okay. So that's the present worth of all the costs. Okay. And so for the benefits, we're going to compute the future worth. So that's going to be something in the future. Okay. And so this is it looks like it's kind of a regular thing here, but you know, now that after we've combined the cash flows in year 10, you know, we only have a uniform series here for 9 years. And so the way that we're going to compute this is first we're going to take that 9 years uniform series, take it to year 0, compute it as a present worth, and then drag that over to the future. Okay? Because if we compute the future worth for this uniform series, you know, it would be in year 9, which wouldn't be the future worth that we're looking for, because we actually want the future worth in year 10. Okay, and so we're going to do this in 2 steps. And so first thing we're going to do is we're going to do 200K. Okay, so let's bring this back to the present day. So the present day is going to be P over A. Okay, we're going to do this at the investing rate, which is 15%. Okay. And this is going to be 9 years, okay, because the uniform series takes place over 9 years. And then to this, we're going to multiply by an F over P factor, because we're converting a present worth into a future series. Okay. And then, oh, question. So the question is, was the 1,300K the MIR? No, the MIR we still need to compute. So the 1,300K, that's just the combined cash flow for year 10 right here. Okay. So this compute MIRR, that's the objective of this problem. Yeah. Okay. Okay. And so after we plug in the values for that, we get the future worth of the benefits to be 3861.5. Okay. Okay. All right. And now that we have the present worth of the cost and the future worth of the benefits, we can plug in and solve for MIRR. Okay. And so we have 1 plus MIRR. Okay. And this is raised to the 10th power because we have 10 years. Okay. Then we multiply it by the present worth of the cost. So this would be minus 1,202.16K. Okay. Plus 3861.5K. And all of it's equal to 0. Okay. And so you do a little bit of algebra, you solve for the MIRR, and you get MIRR is equal to 12.4%. Okay. All right. So in these particular cases, you know, when you have a multiple root problem, you know, you would have to compute the MIRR, you know, in order to get kind of the proper rate of return. Because if you don't, you know, you're going to have like a multiple root system, you know, and it's not going to give you something that's accurate. Okay? And so the nice thing about MIRR is that it's always going to give you just one solution for MIRR. So you're not going to have a multiple root situation. Okay? But as you can see, you know, to compute it, it takes, you know, quite a bit of work and quite a few steps. So, you know, I would say, you know, when you're doing these in practice, you know, try the regular rate of return first and see what you get and see if there's anything weird. And if there's, you see that there might be multiple roots, like you plot the solution, then that's when you would compute the MIRR.
That exponent is 1.5, right?
It's 10.
Oh.
Sorry. So that's the, that exponent is n, which is the number of years right here. So that's going to be 10. Just my iPad is just kind of acting up. Yeah. Yeah, so the n, the exponent's going to be the length of your analysis. So in this case, it was 10 years. So then you pick 10 for that exponent. Okay. All right, any final questions on this? Okay, so that's it for rate of return. So rate of return, I think compared to present worth analysis and annual cash flow, it's a little bit more time consuming, but a lot of people really like it a lot, especially when you're talking about investments, because it gives you kind of a really clear thing where, like, if you have a certain amount of money, the rate of return tells you how much that money is going to grow over time. Okay. And so now that we're kind of done with the big three of the analysis techniques, I want to go over some other techniques that you might find useful. And so this lecture notes is literally called just other analysis techniques. Okay. And so we're going to go over three here. Okay. And so the first one we're going to go over is the benefit cost ratio. And so the benefit cost ratio, it's the name is kind of very descriptive of it, because the end result of the benefit cost ratio analysis is simply just a ratio. Okay? And so in order to compute the benefit cost ratio, this is basically just the formula that you use. Okay? And so what you're going to do is you're going to find first, the present worth of the benefits. You're going to divide it by the present worth of the costs. Okay. Or if you want to do this with annual cash flow analysis, you can do EUAB divided by EUAC. Okay. Okay. And so you'll get the same ratio. Okay. And then you want to see if this is greater than or equal to 1. Okay. And so, if you find that the benefit cost ratio is greater than 1, that means just simply that the benefits outweigh the costs and that this project is a good investment. Okay. Okay. And one other note that I want to make, just because we just got done talking about MIRR, when you're computing this present worth of the benefits and the cost, you don't have to do the same thing that we did before, which is, have just one arrow per time period. So you should get the same answer kind of no matter what, but just to kind of save yourself a step, you can just take all the cash flows just as they are. For the ones that are benefits, go ahead and compute the present worth of the benefits or the EUAB, or the ones that are costs, just compute that straight up. So you don't have to, of course, drawing the cash flow diagram is always helpful, but you don't have to do the same thing that we did before, where it's like if you have one up arrow, one down arrow, you just kind of combine them to one. So this time you don't have to do that. You just have to kind of just compute it as it is. And so one other note that I'll make is that if you want to use benefit cost ratio to compare alternatives and to basically pick the most economically efficient alternative, you're going to have to do incremental analysis the same way as we did before. And so, just like we did with rate of return, like if you want to compare two different, projects or two different machines that you want to buy with benefit cost ratio, you don't just compute the benefit cost ratio of each one individually. What you want to do is compute the benefit cost ratio of their difference in between them, with the higher cost alternative first minus the lower cost alternative. Compute the benefit cost ratio of that, and then that'll give you, your answer, whether that's going to be above or minus 1. Okay. Any questions on this before we jump into an example? Okay. Okay, so let's redo an example that we've seen before. So I think we've done this example for both present worth and for annual cash flow. And so in this example, we're comparing two different machines, and we want to see which one that we want to buy for the company. And so let's say that we have machine A. And so machine A has a $10,000 initial cost. Okay. And also gives a uniform $3,000 each year in revenue. Okay. So that's machine A. Okay, so now let's look at machine B. And so machine B, let's say that has an initial cost of $13,500. It has a uniform benefit of $3,000 a year also. Okay. But this also has a gradient. So each year, after you make $3,000 in the first year, each year after that, we're going to make $500 more. Okay. And so this also has a $500 revenue gradient. Okay. And so if we assume an interest rate of 7% and a period of 5 years, okay. Assuming these parameters, let's determine which machine is the better one to buy using benefit cost ratio. Okay. All right. Any questions on the problem setup? Okay. And so, in this case, since we're performing comparison, we know that eventually we want to do incremental analysis. But since this is kind of the first time that we're computing, benefit cost ratio, I thought I would do each one individually first, and then we can compare that to the benefit cost ratio of the difference. Okay. And so first, let's do benefit cost ratio of each machine individually. Okay. And so let's start with machine A. Okay. And so remember, for benefit cost, we need to compute the present worth, or either the present worth or the EU or the annual worth of the costs and benefits. Okay. So first, let's do costs. Okay. And so in this case, you know, we have a pretty simple case. So the only cost that we have is just the initial cost. Okay, so in this case, our initial cost is just $10,000, right? And we'll just make it a positive number just for, you know, just so our ratio is positive. Okay, and so now let's also compute the present worth of the benefits. Okay, and so the present worth of the benefits is going to be our $3,000 per year, P over A, and then 7%, and then 5. Okay, and so this is going to be 12,300. Okay, and so to compute the ratio, we just simply divide these two numbers together. Okay, so we take the ratio of present worth of the benefits divided by present worth of the costs, then what we get is 1.23. Okay. Right. And so that's all there really is to this benefit cost ratio. It's just you know, you compute everything in terms of just one. You compute all the costs in terms of one type of cash flow. So in this case, we chose present worth. You know, you can do the same thing for the benefits, and then you just take the ratio in between the two. Okay. All right, any questions on that? Okay, so now let's do machine B. Okay, so machine B has a higher initial cost. So machine B has an initial cost of 13,500. Okay, and our benefits, you know, we have our 3,000. That's a uniform series, so that's going to be P over A, 7%, and 5. Okay, and then to this, we're going to add our gradients. We're going to add 500, P over G, 7%, and 5. Okay, and so we take the ratio. You know, what we're going to get after plugging in values from the tables is 1.19. Okay. All right, and so now that we have the ratios for each one's individually, you know, it's again, it's tempting to go and say that, you know, machine A has a higher ratio than machine B, you know, so therefore that's the one that we should pick, you know, in order to invest our money in. But you know, hopefully you're getting used to this old routine. But things aren't, you know, always as they seem until you do the incremental analysis. So let's do that increment. Okay. Okay. And so for the incremental, remember, we want to take the higher cost and then subtract the lower cost. Okay. And so in this case, our higher cost alternative is going to be machine B. Okay. Okay. And our lower cost one will be machine A. Okay. And so let's compute the present worth of the incremental costs and the present worth of the incremental benefits. Okay. And so the costs in this case is going to be pretty straightforward because they both just have initial costs. Okay. And so our initial cost is just going to be the initial cost for machine B, which is 13,500. Okay. And then to that, and from that, we're going to subtract the initial cost of machine A, which is 10,000. Okay. And so we get an increment of $3,500. Okay. And so now we're going to do the present worth of the benefits for the increment. Okay, and so first we're going to take the present worth of the machine B, which is the higher cost alternative. Okay? And so we're going to do 3,000 P over A, 7% and 5, okay, plus the present worth from the gradient. So that's going to be 500 P over G, 7% and 5. Okay, and so that's the present worth from the of the benefits from machine B. And then from this, we're going to subtract the present worth of the benefits from machine A. Okay. And so from machine A, we only just had that uniform series. And so we're going to subtract a 3,000 times P over A, 7% and 5. Okay. And then from this, you see that those two are going to cancel out. And then what we get is a value of 38.50, 38.20. Okay. And so, you know, if we compute the ratio from this, okay, we're simply just going to take 3,820 divided by 3,500, okay, and we get a ratio of 1.09. Okay. Right, and then just like what we did in the incremental analysis for rate of return, you know, because this this ratio of the increment here is greater than 1, you know, we're going to pick the higher cost alternative. Okay, and so just like in rate of return, we kind of had a reference value of the MARR that we were comparing against. In benefit cost ratio analysis, our reference is just kind of 1.1 or 1.0. Sorry. And so if the benefit cost ratio of the increment is greater than 1, greater than our reference, then it's better to invest our money in the higher cost alternative because that gives us you know, a better use of our $13,500 investment in this case. But if the present worth of the or if the benefit cost ratio of the increment is less than 1, then it would be better to invest in the lower cost option because that kind of saves us more money. And so, you know, this benefit cost ratio for doing comparisons kind of really goes hand in hand with the rate of return. So that's kind of why I have these two kind of together because it's kind of the same idea.
So even though the ratio was higher for A, we would still go with B because it's better for the incremental analysis?
Exactly, right. And so you can kind of think of it in the same way too, where like, you know, say that you have 13,500 to spend for the company, right? So you can either go with machine A and pay 10,000 and save that 3,500, or you can spend that entire 13,500 on machine B. And so what this is saying is that machine B will be a more efficient use of that 13,500. And so, you know, actually, if you kind of look back to our present worth analysis and our annual cash flow, you know, we get the same result here, where, you know, machine B was the one that we picked before because it had a higher overall present worth. Yeah. So even though the ratio is different the ratio is higher for A, you know, the total present worth or the total annual cash flow for machine B is higher, and that's reflected in this incremental analysis here. Yeah. All right. Any more questions on this?
So we picked B for that one, correct?
Yes, we picked B. Mm-hmm.
Cool. Thank you.
Okay. All right, so we're just about out of time, so I think that there's not enough time to start the next thing. But on Thursday, sorry, we're going to continue on with this analysis, and so we'll see, you know, some different variations that you can do on benefit costs, and we'll go over the last two analysis techniques, which is payback period and also break-even analysis. So, you know, those won't take too long. Okay? And then I think if we're done with that, then we'll probably start on our next big unit, which is going to be taxes. You know, which is a big thing in the news now, but you know, we're going to discuss just kind of the basics of taxes. Okay, so thank you guys for tuning in today. I'll see you guys on Thursday. So have a great afternoon. You know, I'll have your midterms ready by either later today or tomorrow morning, the latest.
Professor?
Yep.
Could you go back to the beginning where we were talking about. Sorry, I'm trying to find it.
Sure.
Our first exercise where we found the interest rate, we found it to be 50% and 40%, and
Yeah.
then we computed the present worth,
Mhm.
and then we found 30%.
Yep.
So I boxed it. Oh yeah, okay. So I'm missing. All I'm missing is the part where it says pick alternative 2.
Mhm.
All right, thank you.
Yep. Mhm. All right, question. So for question 3 in the midterm, if we don't solve our 120 years, and if we chose present worth, we don't get credit. So you know, I always try to be as generous as I can with partial credit. So if you did try to do it with present worth, you'd have to do it for 120 years. But if you did something less than that, you know, I'm going to give you partial credit on all the work that you did, basically. Yeah. So it's not an all or nothing thing, but you know, I can't give a full credit on it, but then I'll try to give credit for everything that you did right. Oh, yeah. Well, I mean, you know, I'll read the answers as carefully as I can, and you know, I'll try to give as much partial credit as I can. So, yeah. So you know, and you know, afterwards, you know, I'm always open to discuss these answers for the exams too. Yeah.
Professor, in this problem, the 50 and the 40%, and then you get 30%. Why did you assume we were talking about alternative 2? Is it because alternative 2 it has a higher cost?
Yeah, yeah. So alternative 2 here has a higher cost, so that's why we pick it, because the 30% which we got from our increment is higher than the MARR. Yeah.
So since alternative 2 has a higher cost, we assume that 30% belongs to alternative 2.
So this 30% belongs to the difference in between the two. So you can see we did alternative 2 minus alternative 1, and that's the rate of return out of the increment between the two. Yeah.
So if there's a difference, why did you pick up alternative 2?
Right. So the reason we pick alternative 2 is because that difference kind of illustrates what's the most efficient use of that $2,000. And so in this case, you know, you can kind of imagine that we have a fixed $2,000 to spend. And so if we picked alternative 2, then we get, you know, $2,800 from that alternative, right? But if we picked alternative 1, you know, we would spend our first $1,000 and we get $1,500 from that. So that's what we get from that. But the rest of the money, we still have $1,000 left out of our initial pot of $2,000 right here, right? And so what the assumption is, and the reason I give you the MARR, is that you spend the rest of that $1,000 and you invest it at the MARR. And so in this particular problem, the MARR was 10%. And so the return on that investment would be, on that $1,000, you would get back $1,100. And so if you add these two together, $1,500 plus $1,100, then you get $2,600, and that's less than the $2,800 that you got from alternative 2. Yeah.
Okay. And then for the last the last slide, the benefit cost of each machine.
Yep.
You get 1.23 for machine A, and you get 1.19 for machine B.
Yep.
But for some reason, we still pick machine B.
Right. So it's the same kind of mindset here, because machine B has a higher initial cost. But you know, you can think of it as saying that we have $13,500 to spend on something for the company. So like, you know, your manager gave you this check for $13,500. So you can either buy machine A for $10,000, and then this is and then you get $3,000 a year, or you can spend that entire $13,500 on machine B and get that gradient as well. And so, you know, even though individually they have you know, different benefit costs, if you compute the difference in between them, then you can, that's how you basically do a direct comparison between the two, and you find the benefit cost ratio from that. And that kind of gives you the same thing. So this is actually an example we did with just straight up present worth and just straight up annual cash flow. And so if you kind of go back to that, you should see that, you know, we chose machine B in those examples too, because the overall present worth is higher for machine B. And so incremental is kind of the way that we get the same results from present worth and annual cash flow using this benefit cost ratio technique.
So if it would have been less than 1, would we have picked machine A?
Exactly. Right. Yeah.
Okay.
Yeah.
Thank you.
Yep.